Guys, welcome back to the channel and to another video. In this video we dynamically balancing the rotating assembly of a 1600, I think it's a VVL Toyota 20 valve engine. Let me just show you the engine quickly. So these are the components laid out here: the 4 Conrods, pistons, gudgeon pins, piston rings, flywheel bolts, pressure plate bolts, pulleys, crank, and this is the flywheel and pressure plate. So I got to make these harmonic, and let's just first see how much they are out. First I'm going to start on the crankshaft. Okay, so I took the weights individually of the components, as you can see here, and that is all the weights that I'll be needing to put in the computer so the algorithms can work out what the weights are, where, and where the unbalance is once I calibrate it and all that kinds of stuff. But these will all be used individually. First I'll be using the crankshaft as an individual item. Then I'll be putting the front pulley and the flywheel on as two items, and then I'll put the pressure plate on with its bolts and stuff. So first let's set the crankshaft up in the machine and see how out of balance that is, and get that right. Alright, so she's on the machine, she's almost ready to go. Got oil on the journals, belts on, blacks there, my reflector tapes there. Machine is on. Right, so it's time for me to do some measurements on here now. Stick it in there and balance this boy. Okay, so also just on a side note, I'm going to put this thing's operational speed at 5,500 revs, but I'm only going to balance at 750. So in other words, although I'm balancing at 750, the algorithms will work all this weights out at 5,500 revs, like when the engine is actually working at that rev range, 5.5. I'm not going to go to 6,000, 7,000. I mean, that was, you're just going to kill things. That's temporary. Revs 5.5 is basically where the rev will stay most of the time, at speeds and stuff like that. So I'm going to work at that operational speed, 5,500 revs, but my balancing speed is going to be 700. I don't know if I said 700 early on, but anyway, let's put this stuff in the machine now. Okay, so let's just put this data into the machine. Okay, so I got all the information in. Here's my screen that's up. I'm going to start calibrating now. You can see here I got Toyota VVL 1.6 and I'll start calibrating now. Alright guys, so that's running. She's at 700. Like I said, I'm going to do this at operating speed. She's 15 grams at 118 degrees, 7 grams at 167. So let's print this quickly. Okay, so there we have it. 15 grams, 7 grams. Alright, let's zero this out. Alright, so I'm going to turn it now to 169 at 168 on that one there. Let's just turn, and then that will determine where I must take off weight. Okay, so there, that's 168. Okay, so that's now 168 there. So I must grind somewhere here, and then the next one is 119, so I'll turn it back. There you can see that's 119 there, that's on that mark there, and that is on this one over here. Okay, let's play around with this crank and see how far I get. Right, so I've been working the crankshaft a little bit, and you can see I'm down to 10 and 2 now, so we are getting closer. I'll keep on going at it. Okay, we're running again after grinding. Let's see, going up to 700. And we're down to 3 and 1.3, so we're creeping in slowly but surely. Okay guys, so this is the crankshaft done. As you can see, we are 0.26 and 0.32, slightly off the center, but I mean that's neither here nor there. The main fact is that we're under half a gram out, so the crankshaft is perfect. So let's just print this quickly. Let's just compare quickly. So in its unqualified state, you can see there it was 15 grams out at 118 and 7 grams out at 167. Like I said earlier, it doesn't sound like much, but that's a lot at high revs. With the inertia and all that kinds of stuff, centrifugal forces and stuff, that's quite a lot for a crankshaft. And then I brought it down to 0.26 and 0.32, so I mean that's as near as damn it. Right, so as far as the crankshaft go, I had to grind quite a bit here, because again this lobe was actually as high as this one, but I had to take quite a bit off. And then I touched a bit in this corners here, all at this plane here, to get that 15 grams out. I mean 15 grams is a lot. There wasn't place for me to drill a hole here, because this was quite on the edge, you know, like this. I couldn't drill a hole there, that means I had to drill there, so that's why I just took that off. And on this plane here, I touched it here, I drill a small hole there, and then I had to work this corners here. So anyway, this is the crankshaft all done now. Okay, so as far as the crankshaft go, that's now done. That's 0 in my eyes, all balanced out. So next is the flywheel with the pressure plate and the front pulley. Let me just stick that on, and also I must adjust the machine also to accommodate for the diameter of the flywheel, so I have to do some adjustments there. But anyway, I'll carry on. Okay, so let's just weigh the flywheel bolts. 26.84. And 26.80. So they all weigh 26.8. The second decimal I'm not going to be bothered with. That could just be dirt or something on here, but I mean that's seriously nothing. So yeah, let's carry on. Right, so there she is on the machine. You can see I had to shift this back to accommodate for the flywheel diameter. And I got a rod inside the crank as a stop, and this side I got that in, so that's the pulley and the flywheel all ready to be balanced. And I'm going to use this mode here, bearing mode 2, because I'm balancing. Remember that in the middle, that's the crankshaft, which is 0. I'm measuring the flywheel this side, I'm measuring the pulley this side, so I'm using bearing mode 2. So I'm going to just measure A, B and C and stick it in the computer. Alright, most of the data is caught up now. I must just do the calibration and the arithmetic and the calibration. But it's worth knowing that I set again the operational speed of this engine at 5,500. So that means that the computer will work everything out, all the balances and tolerances at 5,500 RPM. But I put the balancing speed down to 500 and not 700, simply because I got this extra weights on, so like I said, the balancing speed is really not that important. It's the operational speed. Anyway, I'm going to capture the rest and then I'll get going. Okay, so I've done all the calibration and she's at 504. I can turn that slightly down and you can see she's 1.21 grams out on this side at 99 degrees and 8.23 at 227 this side. So this side is quite a bit out. I think it's because this thing was welded on afterwards. This trigger wheel was welded on afterwards. Anyway, let's print this. Okay, so there we go. VVL flywheel pulley. 1.21 on the flywheel side. That's not too bad actually. And 8.23 on the pulley side. Like I said, the trigger wheel was welded on afterwards, and I think that is what threw this pulley out. But let me just show you quickly. Okay, so here you can see there's a lot of notches in this pulley. There's a whole chunk missing here. And this pulley took some damage over the years, and this trigger wheel was welded on there and there and like on this side, so the welds are not also symmetrical to the center, which is also throwing it out. But anyway, I'm here to correct it. Right, so let's start. Alright, so I worked this a little bit. I drilled a hole there and I grinded slightly here, and you can see here we're down to 0.97 where we started at 1.5 or 1.2, I'm not too sure, and this we started at 8 and we're on 4, so we're halfway down here, and we're heading in the right direction. Alright, we're back at it. 500.7, 1.1, so we're getting there. Alright guys, so this is the flywheel and the pulley, and I got it down to 0.28 and 0.34. Not exactly in the center, but acceptable. So this 0.28, which is slightly out, is flywheel side, but remember I must still put the pressure plate on, so I'm not too concerned about that. And 0.34 is not exactly in the center, but when I put the pressure plate on, it will affect the pulley on this side. But as far as dynamic balancing go, this component is sorted. Okay, so let's print this quickly. Right, so here's the comparison. When we started it was 1.21 at 99, and it came to 0.28 at 130, which is acceptable, qualified. This one came to 0.34, and this, when we started, was 8 grams. This was actually quite a lot out. Like I said, I think it was the wells on the trigger wheel that was added to afterwards. So anyway, this is good to go. Now I'm going to put on the flywheel. Right, I got the pressure plate on, and she is 8 grams out, and you can see how it affected this, because early on this was 0.32, I think it was. You can see that's gone up. So as I take off weight there, that should kind of become less and less up. Let's just print this quickly. Okay, this is the pressure plate. It's 8.76, 1.81 on the pulley side. So that's how they affect each other. And you can see before I put the pressure plate on, it was 0.34. So it was not too bad actually. Let's just work on the pressure plate now. Alright, so I'm still busy balancing the pressure plate to the assembly. And you can see I'm down to 3 and 0.87. So you can see as I'm taking off here, it's affecting this side. I've done absolutely no work this end. I didn't touch this side, because I mean this was all in balance. Only thing I added on was the pressure plate, and as I'm bringing that down, it's affecting that, so everything will start moving in gradually. So yeah, let's work on this some more. Okay guys, so this is now the flywheel, and as you can see there, she's on to operating balancing speed 0.17, 0.33. So this came down almost to where it was prior to me putting on the pressure plate. I think it was 0.32. So this thing is perfectly sorted. So let's print this quickly. Okay, let's make the comparison. So there we go. We started at 8.76 at 55, came down to 0.17 at 109, and 0.33 at 297. You can see here, prior to the pressure plate, where's that one? Just give me a sec. Prior to putting the pressure plate on, they say it was 0.34, and just working the pressure plate and not touching the pulley at all, it came down to where it was actually, well, I mean, really that difference 0.101, 0.01 is actually nothing. So anyway, this bottom end is sorted out. Next is the pistons and conrods. Okay, so let's just get down to what I had to do to balance this thing. On the inside, I decided to drill a hole there, on the inside of the pulley, and on the outside of the pulley I drilled a hole over there. You can see that's a fresh hole, and I think there's two more over there. There's that two over there, and then this thing was sorted out, and that two there, sorry, and then this was the pulley sorted out. And on the flywheel I drilled two holes there, and I think there's another, and over here, these holes here. And on the pressure plate I drilled a hole there, and this lot of holes here. That's general practice, and she sorted out. So, okay, now the reciprocating parts. Alright, so this lot is next. I'm going to just stick that set of circlips in the pistons. I'm going to mark the pistons, start weighing, and see where we're at. Okay, circlips are in and they're marked, so let's weigh them down. Okay, so I changed my mind. I took the numbers off so that it doesn't reflect to a specific cylinder. So I'm just going to put like a letter, like, you know, MNOP or something to that effect. And then same with the Conrods, just to when I start matching them up. Anyway, so I'm just going to change that there. Alright, so I've done them WXYZ, and I'm just going to put it down on the board here, X, Y, Z, and this is now where I'm going to put the weights down. So let's measure the first one. Right, so these are the weights of the pistons. This is the Conrods that are laid out in the order that they were laying here. I wrote it out like that. And then I put the heaviest, not Conrod, sorry man, gudgeon pins. I put the heaviest gudgeon pin, which is this one. I put it with the lightest piston. Second heaviest gudgeon pin with the second lightest piston. And then other two is the same, and I just stuck them wherever they are. So now I want to measure them as a group now. Okay, so I put the rings with the pistons. Now I want to use the bigger scale because this weight exceeds this weight's capacity now. So let's just put the scale on. Okay, you can see she's on 0. And let's take W. And let's see what W weighs. 0.415 is W. Let's just write that down. Okay guys, so as you saw, they're actually all down to 0.415. All of them. This was the original weights here. They were quite close. They were all, this one was just like shy short of 294. Anyways, I mingled, as you saw, I mingled up the various weights to the different ones. These here were the weights of the piston rings that are also interchanged, but I'm not too concerned about the piston rings. But they all weigh the same. As you saw there, they're all down to, I mean, they're all exact, the pistons, the way it's set up now. So I'm going to mark this so that the gudgeon pin don't get mixed up with the rest. I'm going to give them a mark, and that is the set now, 0.415. Next I'm going to do the Conrods. I'm going to put the big end bearings in there. Okay, so I weighed all these things. This one was 150. This one here, this one was 145. This one here was 141. And this one here was 140. Trying to get the focus here, this 140. So this is the lightest one, so I must grind all of them down to 140. Okay, let's start. Alright, so they all sorted out, they all weigh 140. This is where I grinded them. And this one obviously I didn't touch because this was the lightest one, so this one remained the same. So this one was 140, they all weigh 140. Probably like 140.13, you know, like those funny little micro digits at the back. I'm not going to be bothered with that as long as the main weight is there. Alright, let's do the slot here now. Okay, so I weighed them. This one was 395. This one was 410. This one was 415. And this one was 410. What you can see here is a mismatch of bolts here, of nuts I mean. You can see this one's nut here. This one is more of a splined nut on this one. These are all hexes. So with a spline, there's obviously more material taken off the nut itself compared to a hex. And I think that's where the difference in the weight comes in. Why this one is 395 and these are all heavier, 410, 415 and 410. So I'm going to bring this 3 down to 395. Alright, let's carry on. Alright, so this is the rods done, guys. This was the one that I didn't have to touch. You can see the edges here. And the one I didn't have to touch. And these that I actually grinded to bring the weights down. I actually took that sharp edges off. I didn't have to take so much of this one because I think this one was the 410. This one I took the most of. This one was the 15, the 415. So that's how that came out. And this was the other one. So they're all 395 point whatever, insignificant. So this is all done. Pistons are done. Crankshaft is done. Alright guys, engine's complete. The bottom end's completely balanced out. Hope you enjoyed the video. If you did, give it a thumbs up, comment and share. Don't forget to hit the subscribe button, notification bell, and I'll catch you on the next one. Cheers for now.